Welcome to our step-by-step guide on using the data editor. This presentation is designed for economics and research students who are new to data management. We'll cover the essential first steps of any quantitative analysis, entering numeric and string data, and properly defining your variables. As the quote by Clive Humby suggests, data is incredibly valuable, but only when it's refined and structured. That's our goal today. The first challenge in any analysis is dealing with raw data. It often comes in mixed formats, contains missing values, and has inconsistencies. This unstructured information is what we call raw chaos. It's human-readable, like a survey form, but not machine-readable. Our goal is to use a tool like the data editor to transform this chaos into structured insight, a clean, organized dataset ready for statistical analysis. This process is critical. Without a proper structure, any analysis will fail, embodying the principle of garbage in, garbage out. Think of raw survey responses, where one person writes male, another M, and a third leaves it blank. A computer can't analyze this directly. We need to standardize it, perhaps coding male as 1 and handling the blank response appropriately. To manage this transformation effectively, we need a clear, systematic process. Let's look at the methodological framework for this. Here is the standard workflow for data preparation. We start with raw data. The most critical first step is to define variables. This is where you create the blueprint for your dataset in what's called the variable view. Only after defining the structure do you enter data into the data view. Finally, you proceed to data cleaning and statistical analysis. This brings us to the golden rule of data entry. Never enter data before defining your variable properties. You must define the structure first, then input the values, and finally verify the integrity. When defining a variable, the first question is, what does the data represent? There are 3 main paths. If it represents quantities, like wage or GPA, you should use the numeric type with a scale measure. If it represents text identifiers, like names, use the string type with a nominal measure. However, this type is very limited for analysis. If it represents categories, like gender or region, the best practice is to use the numeric type with value labels. For example, you code male as 1. This is because computers process numbers much faster than text. The general rule of thumb is to use the numeric type for almost everything. String variables cannot be used in many statistical tests like t-tests or ANOVA. Numeric data is the standard for all statistical operations. It allows you to calculate the mean, standard deviation, variance, and so on. For categorical data, we use a technique called coding, creating what are often called dummy variables. This transforms qualitative concepts, like male, into quantitative inputs, like the number 1. This is essential for including them in regression equations, such as y equals alpha plus beta x. String data is pure text. It has no arithmetic properties and should only be used for identifiers, not for variables you plan to analyze statistically. This entire process of translating real-world concepts like satisfaction into measurable variables like a Likert scale from 1 to 5 is a core concept in research called operationalization. To study the effect of gender on wages, we can't put the words male and female into a regression. We operationalize gender by creating a dummy variable, dgender, where it might equal 1 for female and 0 for male. Then we can estimate the model, y equals beta 0 plus beta 1 dgender plus epsilon. Beyond the variable type, we must also correctly specify the level of measurement to ensure our statistics are meaningful. There are 3 main levels of measurement. First is scale, also known as metric. This is continuous data, where the distance between units is meaningful and equal, like income or height. Second is ordinal. Here, the data has a clear order or rank, but the distance between the ranks is unknown. Think of rankings like first, second, and third place in a race. Third is nominal, or categorical data. These are unordered categories with no inherent rank, such as gender or region. It is critically important to set the correct measurement level. Using the wrong level leads to invalid statistics. For example, if you code gender as 1 for male and 2 for female, the software can calculate an average gender of 1.5. This is mathematically possible, but economically and logically nonsense. In SPSS, every variable has two identifiers, a name and a label. The variable name is for the machine. It must be short, unique, and have no spaces, like HR wage 24. This is what you use when writing code or syntax. The variable label is for humans. It's a longer, descriptive field where you can provide context, like hourly wage in 2024 USD. This label appears in your charts and output tables, making them easy to understand. The best practice is to keep names short for efficient programming and make labels detailed for accurate, clear reporting. The name tells the computer what to do. The label tells you what it means. A variable name might be EDUCAC years. It's short and easy to type in commands. Its corresponding label would be years of completed education, which is what you'd want to see as the title on a graph. With these foundational concepts in mind, let's take a quick tour of the SPSS user interface where we'll apply them. This slide covers the SPSS graphical user interface navigation hierarchy, focusing on how to access different views and functions within the data editor. We'll look at essential breadcrumb paths for starting fresh, switching between data and variable views, toggling value labels, and defining variable properties. For example, to start a new data file, you'd navigate through File, New, Data. To switch between data view and variable view, you can go to View, Variables, or use the handy Pro shortcut, Control-T. This shortcut instantly toggles between data view and variable view. We also see how to toggle codes and labels via View, Value Labels, or by clicking the 1A icon, and how to define variable properties through Data, Define Variable Properties. Understanding these navigation paths is crucial for efficient data management in SPSS. The SPSS data editor has two main interfaces, which you can toggle between. Think of them as the blueprint and the building. Variable view is the blueprint. This is where you design your data structure. Each row in this view represents a variable, and the columns are for its properties, like name, type, and label. Data view is the building itself. This is where you enter the actual data or observations. Here, the rows represent cases, like individual survey respondents, and the columns represent the variables you defined in variable view. Our mission is to correctly input data from a student survey into SPSS. The survey collects name, gender, GPA, and financial aid status. The most important part of this mission is following the correct procedure. Step 1 is crucial. Do not type any data yet. Step 2 is to go to variable view first. We must build the container for our data before we can pour the data into it. In variable view, we create our first variable, named GPA. The type is set to numeric. A key tip is to set the decimals property to match your raw data. Since our GPA is 3.50, we set decimals to 2. For the label, we provide a descriptive name, cumulative grade point average. Crucially, we set the measure to scale. This tells the software that this is a continuous numeric variable, which is required if we want to calculate statistics like the mean GPA later on. Now, let's look at defining categories for a variable like gender using value labels. Even though gender is a category, we define its type as numeric in SPSS. Within the Values column, we open the Value Labels dialog box. Here, we assign a numeric code to each category. For example, 1 is assigned to male and 2 is assigned to female. This feature is incredibly powerful. It allows for quick data entry by typing simple numbers like 1 or 2, significantly reducing typing effort and potential errors. Yet, when you view your data or reports, SPSS displays the clear, meaningful labels, male or female. This ensures that your output is easy to understand without sacrificing entry speed. It makes your data entry both efficient and error-proof. For the student's name, we create a variable named student name and set the type to string. When you select string, you must specify the maximum number of characters it can hold. It's good practice to set this to a reasonable length to avoid cutting off long names. A key limitation of string variables is that they are case-sensitive. To the software, John is not the same as John. Because of this and other limitations, you should use string variables primarily for identifiers, like names or open-ended comments, not for variables you intend to use in statistical analysis. Now we switch to the Data View tab. You'll see the columns Student Name, Gender, and GPA that we just created. We can now enter the data for our first student, Gwen Vaughn A in the Student Name column, 1 in the Gender column, and 3.50 in the GPA column. Notice that even though we typed 1 for gender, SPSS may display the label male if value labels are turned on. This provides immediate visual confirmation that the code is correct. This process demonstrates an important safety feature. If you try to type text, like good, into the numeric GPA column, SPSS will reject it. This input check prevents data entry errors and is a direct benefit of defining our variables first. A crucial aspect of data integrity is distinguishing between a genuine zero value and actual no data or missing information. For instance, a student having an income of 0 means they have no income, which is different from a scenario where their income data is simply unavailable. This distinction is essential for accurate mean calculations and other statistical analyses. In the variable view, we can define specific discrete missing values. A common practice is to assign an out-of-range numerical code, such as -99, to represent missing data. When you input -99 into a cell, SPSS recognizes it as a placeholder for null, not as an actual negative number. This ensures that these cases are correctly excluded from statistical computations, such as the mean, thereby maintaining data integrity. For example, if you're calculating the average GPA and a student's GPA is missing, defining -99 as a missing value ensures that SPSS excludes that student from the calculation, preventing an artificially lowered average. After handling all missing data, the next critical step before analysis is to verify all our entries. The validation rule is simple. Always run descriptive statistics immediately after data entry. This is your first line of defense against typos and data entry errors. It's much easier to fix a mistake now than after you've run complex models. When you get the output, scan the minimum and maximum columns for impossible values. For example, a GPA is typically on a 4.0 scale. If the output shows a maximum GPA of 4.50, you know you have a typo. In this example table, the maximum for financial aid is 5,000. This looks suspicious and should be investigated. It might be a typo for 500. Catching these errors early ensures the integrity of your subsequent, more complex analysis. For advanced users, defining data structures and entering data can be done much faster using syntax, which is SPSS's programming language. Using code ensures reproducibility. Anyone can rerun your script to get the exact same dataset, which is a cornerstone of good science. This code snippet shows how to define variables like ID, gender, and GPA, assign labels, and even input the data, all without clicking any buttons. A great tip is that you don't have to write this from scratch. In any SPSS dialog box, instead of clicking OK, you can click the Paste button. This will automatically generate the corresponding syntax for that action, which is a fantastic way to learn the language. To summarize, the core takeaway is that good analysis fundamentally begins with good data entry. A clean and well-structured data editor is the prerequisite for achieving reliable and clean results in any statistical analysis. The